Hey guys, I thought I would really quickly run through one of the example problems from today in class just to help you understand how to put this stuff in your calculator a little bit better. So here we have problem number 3 that said we want to use our exponential model to set up this table and then try to figure out what the function is or what equation would model this situation based off those data points. So the first thing we want to do is put this data into our calculator. So we're going to come here to our list menu, except we're just going to click stat. We do not need to click a second. So then we're going to go to edit my lists. My lists are already clear, but if they weren't, I could come up here, highlight the L1 and clear it out. That would then reset it. So I'm going to enter in my values of 0, 5. This is slightly off on the computer, so bear with me. So then enter in your values if you've not done so already. And of course, my x values are the amount of time that has passed in this situation since the coffee has been put in the cup. 203. My first list here is the temperature of the coffee in degrees Fahrenheit. So you can see the longer that the coffee has sit in the cup, the cooler it is getting. And 104. So there we go, my list should have the same amount of values in both of them. So then if I want to see this in my graph, like here in step 1 it says to plot the data, I want to come over here to my graph, but as we can see there's nothing in there right now, there's nothing in my y equals. If I go to second y equals, I'll get to stat plot. I want to turn my plotting on. So I come into my plot menu, I tell it on, I can show what kind of plot I want. I just want it to put the dots where they belong. My first list is going to be L1, my second list will be L2, and I'm going to go ahead and leave these boxes, so if I try to model a line through it, I'll be able to see directly where the line actually fits or not. I hit second, do not hit second, I just go to graph, and I check it, but notice my window will be nowhere close because my x values go from 0 to 30, my y values are all above 100, so I'm going to need to come fix my window. I'm just going to start it at 0, and let's go to 40 so we can go further than we actually need to see. My y values, I'm going to just go ahead and start at, let's just do 0 just for fun. I'm going to do 220 so that I'm higher than the actual max value that I need, and I'll make my scale 22 just so it's a tenth of my range. Makes my life easier and makes my scale look better. So then when I go graph it, I see my points on the graph right here. We can see that if we were to draw a line through it, it would look like an exponential situation. And we will look at how we find that here in just a second. Notice that here we see the asymptote is assuming that it's going to be y equals 0. Since my asymptote here would not be y equals 0, there's no way that the temperature of my coffee will ever reach 0. We're going to shift this. So I come back into my list editing. I make L3 list. Now I go up and I highlight L3 and I click on it, enter, so that my box down here is blinking, waiting for me to tell it what I want. I want that list to be list 2, but then minus 68 degrees, because room temperature is approximately 68 degrees. So we take 68 degrees away from that list to make the asymptote then be 0. It's kind of compensating for the fact that I cannot reach 0 in this situation, cannot even have an asymptote of 0. When I hit enter, it populates all my values for me, saves me time. Instead of having to compute all those, the list generates it for me. I go back to my stat plot menu. Again, that's a second y equals. I go to my second plot and I turn this plot on, but now my lists are going to be L1 and L3. So notice my L3 is just above the number 3. And I can leave those as boxes, but I'm going to make them plus signs actually so that they look different and I can obviously tell what's what. I now see this data would actually have the asymptote of 0. So that is the list set that I want to use when I'm generating my equation. We always want our asymptote to be what it should be. So in this case, a y equals 0 asymptote to get that exponential regression. So now to do the exponential regression, we now come back over here into my stat menu, but instead of just hitting stat, I hit second stat, which takes me to my list menu. I can go to operations, I can go to my math, I can check out all this stuff. Actually, sorry, I misspoke there. I don't want to hit second. I just want to go into my stat menu and go to calculate, exponential regression is right here. So again, if I clear all the way out, I'm going to go to stat, calculate, down to exponential regression. I click exponential regression. I tell it my first list I'm going to use is L1, not L4, L1. My second list I'm going to use is L3. And then when I hit enter, it's going to do all the math for me to tell me what my A and my B would need to be in order to make this true. Notice my A, 134.51, matches all the way out the decimal places if I were to check it. My B, 0.95 at 6011669, that matches all the way out. And my other values don't matter right at the moment. That's why I don't have these. Some of my settings are different than what would be here. So then I go ahead and write these values down, and I set up my equation in this form. However, because we subtracted the 68 away to get this form, to actually model the line that matches my original set of points, I'm going to need to add that 68 back in. So if we want to see that, I take those values of 134.5, and of course I'm going to be able to round a little bit, so we just round it off there. I plug in 0.956 here, again rounding a little bit. I raise that to the power of x, but now I'm actually going to have to add 68, so I get a little parenthesis happy. I go ahead and encompass all of this in parentheses and then add the 68 after it. So when I do that and I go up to my graph, I now see that the line models perfectly to match up with those data. I actually go straight through 4 of these data points. That's why we like using the boxes. You can see exactly where you hit it. This one's slightly above, this one's slightly below, but it still is a pretty good representation. If I then wanted to find out how long it would take for the temperature to reach about 185 degrees, I can just come and make a table with that function that I'm using now. So again, I can check, there's my function. I can go to that table, and I can go to my table settings. So again, I can go second here. I want my independent variable to be ask. And again, I'm a little glitchy because I'm on the computer. So I make this go to ask. Now I can come back to my table, and now it wants to know what I'm asking. Well, what I'm asking is how long has it been in the cup? So, well, when it's been in the cup 2 minutes, when it's been in the cup 3 minutes, and I see I'm getting close to my 185, so then I can start getting more precise. 3.1, 3.2, and we see right there is where I passed it. So between 3 minutes and 3.1 minutes, so right around 3.1 minutes, it dips below that 185 degrees. So that's how they got that answer right there.